Hello everyone and welcome to the class. Today in our lecture we are going to discuss about how the IP addressing helps for IP routing. So IP defines the network layer addresses that identifies any host or router interface that connects to a TCP IP network. Any interface that expects to receive the IP packets needs an IP address. So there are some rules for groups of IP addresses. These IP addresses in networks or subnets. TCP IP groups. The groups IP addresses together so that the IP addresses used on the same physical network are the part of the same group. IP calls these address groups an IP network or IP subnet. So IP defines these address groups on an IP network or IP subnet. It has some specific rules about which IP address should be in the same IP network or in the IP subnet. Numerically, these addresses in the same group have the same value in the first part of the addresses. From the perspective of IP routing, the grouping of IP addresses means that the routing table can be much smaller. A router can list one routing table entry for each IP network or a subnet instead of one entry for every single IP address. The two IP addresses not separated from each other by a router, they must be same in a same subnet. Two IP addresses separated from each other by at least one router must be in different groups or subnets. As per the rules, host on the top Ethernet addresses start with 150.150.1. Host on the router 1, router 2 serial link 150.150.2. Host on R2, R3 EOMPLS link 150.150.3. Host on the bottom Ethernet addresses will start from 150.150.4. A router can list any one routing table entry for each IP network or subnet instead of any single entry for single IP address. So before that, IP header. All the routing process also make use of IPv4 header. Header lists a 32-bit source IP address as well as 32-bit destination IP address. While the routers remove or add data link headers each time it routes a packet. So IP header remains with the IP address unchanged by the routing process. How this IP routing protocols helps IP routing. For this routing logic to work on both host and routers, each host and router need to know something about the TCP IP interwork. Host need to know the IP address of the default router so that the host can send packets to the remote destination. Routers need to know routes so that they forward packets to each and every reachable IP network or IP subnet. The best method for the routers to know all the useful route is to configure the routers to use the same IP routing protocol. A network engineer could configure all the required routes on every router. If you enable the same protocol on the routers in a TCP IP interwork with correct settings, the router will send messages to each other. As a result, all routers will learn all the routes for all IP networks and subnets. IP supports a small number of different protocols. All use some similar ideas and process to learn these routes. But different routing protocols do have some differences. Otherwise, we don't need any more different protocols for this. So what are the steps for learning these routes? Each router, independent of the routing protocols, adds a route to its routing table for each subnet directly connected to the router. Each router's routing protocol tells its neighbors about the routes in the routing table, including the directly connected routes and routes learned from other routers. After learning a new route from a neighbor, the router's routing protocol adds a route to its table, while the next hop router of that route begins the neighbor from which the route was learned. So we have some steps so that it can learn all the routes differently. So these are the steps for learning the routes. Thank you.